Estimating a population mean. Example 12. All right. I hope you read the question ahead of time. You will notice, and I understand the information doesn't always come in the order we need it, and I would just tell a person again, when you're doing this assignment, the first thing I think is, are you doing a confidence interval, or are you supposed to find a sample size? And right here, find the 90% confidence interval for the mean. Confidence interval, confidence interval. All right, Mr. Soda Cracker's flow chart. Is the given standard deviation from a population or a sample? Obviously, that's the key question. I don't know. Flip a coin? No. Read the question, look for the words, standard deviation, and see if it represents an overall large group, population, or if it came from a relatively small group, sample. So, here's standard deviation right here, right? Sample. Oh, my goodness. With a sample standard deviation, sample standard deviation, circle those words. Sample standard deviation, sample standard deviation, standard deviation, sample. All right. Now we read the question to see if it says that it's normally distributed. Sorry, I'll get out of your way. Read the question. Does it say anything about the population being normally distributed? Reading, 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 do 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 do. If the population is normally distributed. Well, indeed it did say that, didn't it? Oh my goodness. Okay, the standard deviation was a sample. It said it's normally distributed. Here we are. X bar plus or minus t, alpha over 2, s over the square root of n, degrees of freedom, n minus 1. Bang. Follow the flow chart. Not sure what else to say. All right. Now, you know a lot of times what happens? Way too often, I'll say it one more time. Wait a minute there, Mr. Sopapilla. They only surveyed 20 teachers. The problem I see way too often is people jump down here, check the sample size, less than 30, they write this in the box, they say they're done. No! The fact that it said that the population is normally distributed bypassed that question and took us straight to the formula. Is the population normally distributed? Yes. Here it is. We never needed to check the sample size. Woo! Normally distributed superseded that. All right. All this screaming gets to me. All right. X bar would be the 16. That was the mean of the sample. S would be the standard deviation, which was 2. N would be the fact that they sampled 20 teachers. And then, of course, the T and the degrees of freedom all goes together, doesn't it? So, in order to get that going, you know, to me, this one is less reliant upon drawing a picture, but I still like to do it anyway, all right? A symmetrical distribution. And the two things that are important are the fact that they want 90% confidence interval, and the fact that the degrees of freedom would be the sample size of 20 minus 1, 19. 90% confidence, 19 degrees of freedom. Those are the things we need. And here we go. Go to the T-table. Confidence interval, see that at the top there, upper left? Come over here, 90%. We're in that column right there, aren't we? 90%. 19 degrees of freedom over here on the left. Look for the intersection. The intersection of 90% confidence and 19 degrees of freedom is 1.729. I hope I'm reading that right. 1.729. So we have positive 1.729 over here and negative 1.729 over here. And they're both, as I keep saying, baked into the formula, plus or minus. Number crunching. Put that in the calculator. Okay, we're far enough along I gotta assume you can do that. That would be your margin of error. You're gonna take 16 and subtract that margin of error to get the lower end of your estimate. And you're going to add that margin of error, right? You're actually doing minus and plus, whatever. But remember, this is the smaller number, this is the larger number, and the smaller number is always the minus, and the larger is the plus. So 16 minus this goes here, 16 plus this goes here. If you get them backwards, I'm supposed to count it wrong. So just help me out. Don't get them backwards, all right? I'm supposed to count it wrong, and I don't want to. So don't give me that dilemma, all right? And if you do the arithmetic on that, and that's just arithmetic, what a snob, we're in college. But anyway, your interval would be from 15.23 to 16.77. And there again, the rounding is arbitrary. Sorry if I'm not clear about that, but I promise you I won't make it an issue when I'm grading them. So, show me the right formula. Here's how I grade them. Did you get the right formula? Did you get the right number from the appropriate table? And then these, if you did everything up to that point right, you're probably gonna get this okay. Don't get these backwards though. Okay, that hurts my heart when that happens. All right, one more, let's do one more.